Hello students, welcome to lesson 4. In the last 3 lessons we have seen the trigonometric ratios and then properties and then examples based on trigonometric ratio. In this lesson, angles. So the trigonometric ratios of some specific angles, standard angles or specific angles means, see, in geometry there are certain angles which you can construct without the help of protractor. Protractor is the measuring instrument of angle which is there in your geometry box, but there are some angles. For example, 90 degree you can construct with compass only. Similarly, you can construct 45 degree because you can divide the 90 degree into two equal parts, so it is 45 degree. Similarly, 30 degree you can find because you can construct an equilateral triangle where there will be 60 degree angle, so which you can divide, so that will be 30 degree. Like that, this type of angles are called standard angles. That is, angles which can be constructed without the help of protractor, only using compass. So this is the concept of standard angles. So in your textbook it is given specific angles. So here what we are going to do is, we are finding the trigonometric ratios of some specific angles. Let us proceed. See, trigonometric ratios of the following angles we can find. One is 0 degree, then 30 degree, 45 degree, 60 degree and 90 degree. So, for example, sine 0 how much, cos 0 how much, similarly sine 30, cos 30, all the 6. So, this is the idea. Now, first let us find trigonometric ratios of 45 degree. Consider the triangle ABC. Now, let B equal to 90 degree here and let C equal to 45 degree. So this angle is 45 and you know how to construct this type of triangle. Now what happens is, whenever C is 45 degree, B is already 90, A should be 45. This is because angle sum property. You know that in a triangle, sum of the angles must be 180. B is already 90. Therefore, other two angles sum should be 90. So, if C is 45 degree, A also should be 45 degree. This is one important thing. Then, hence here what happens is, in triangle ABC is isosceles triangle because if the angles are equal, the opposite sides are also must be equal, corresponding opposite sides. Therefore, what happens? BC must be equal to AB because A is 45 degree, C is 45 degree. So, the opposite sides also must be equal. So, this is the idea. Now, therefore, what we do is, let us take BC equal to AB equal to say A, small a. Therefore, length of the side is A and A. So now look at this triangle ABC. Base is A and the vertical side is A. Hypotenuse, you can, using the Pythagoras theorem, you can find the length of AC. Therefore now AC will be equal to square root of AB square plus BC square. Therefore substitute to get A square plus A square. Simplifying we get A root 2 because it is 2A square. When you take square root, it is A root. Therefore, the hypotenuse is A root. Now, in the given triangle, we know the sides BC, AB and AC. Therefore, definitely we can find all the 6 trigonometric ratios. Now, find sin C, for example. Sin C is sin 45. That is equal to, what is the definition? Opposite AB divided by hypotenuse AC. So, that will be equal to A divided by A root 2. Cancelling A, you get 1 by root. Therefore, sin 45 degree is a constant value, that is 1 by root 2. So, this is the value. Similarly, cos C will be equal to cos 45 degree, that is equal to BC by AC. Once again A by A root 2, that is also 1 by root. Therefore, sin 45 degree and cos 45 degree, they are equal. Next, tan C equal to tan 45 degree. So that will be equal to opposite side EB divided by adjacent side BC, but both are equal. You can see it is A by A, so it is 1. Thus, we have seen sin 45 degree, cos 45 degree, tan 45 degree. Now you need not worry about the remaining three trigonometric ratios because cosecant 45 degree is reciprocal of sine. So it is root 2. Similarly, therefore, in remembering the values, you need not worry about all the 6 ratios. It is just sufficient if you remember sine, cos and tan. Remaining 3 are the reciprocal ratios. Therefore, definitely you can write it by remembering these things. So this is the first set. So trigonometric ratios of 45 degree. Next, remember this. So you have to remember the values also. Sine 45 degrees 1 by root 2. Cos 45 degrees also same. And tan 45 is 1. Now, next one is, of course, you can remember like this. What is cosecant 45 degree? It is reciprocal of sine. Therefore, definitely it is root 2 because there it is 1 by root 2. Similarly, secant 45 degree will be equal to root 2 and cot 45 degree will be equal to 1 because 1 by 1. So this also you can remember, but as I told you, there is no need to memorize these additional 3 ratios. It is just sufficient if you remember sine, cos and tan. So these are the 6 values. Next, let us take the second case. I am taking together, even in textbook also they have taken it together. 30 degree and 60 degree we can find together using one single triangle. Let us see how it can be done. So here, of course, procedure is a little bit elaborate, lengthy. Therefore, you have to be very careful. Consider an equilateral triangle ABC. You know what do you mean by equilateral triangle? All the 3 sides are equal. A, B, C is an equilateral triangle. Now, what is the property of equilateral triangle? Now, let AB equal to BC equal to CA equal to 2A. Therefore, let us take it as 2A. So, 2A, 2A and 2A. Now, what I do is, angle B is 60 degree. We need 160 degree angle. Therefore, of course, angle B is also 60, A also 60, C also 60. So all the 3 are equal. Therefore, I have just noted one angle that is 60 degree because I want to find sine 60, cos 60, etc. Now what we have to do is draw AD perpendicular to BC. And you know from the property of equilateral triangle, see here, when you draw the perpendicular, this is the thing you have to remember. Suppose D is the point where the perpendicular meets base BC, then you know this one. Then AD bisects angle A, very important. AD is the bisector. This is the condition for equilateral triangle. Second one is, it also bisects the side. AD bisects the side BC also. So these are the two important aspects in equilateral triangle. Now look here. What about BD therefore? Because BC length is 2A and D is the midpoint of BC. Therefore BD will be equal to A. So this is one important thing. Then second one is angle BAD is 30 degree. That also can, because it bisects, so 30 degree. Now look at this triangle ADB. So now in the triangle ADB, AD equal to, because I have to calculate AD also. So the height of the that is altitude from A. So using Pythagoras theorem, because in triangle ADB, BD is A and AB, which is hypotenuse, that is 2A. Therefore, AD other side will be equal to hypotenuse square, that is AB square minus BD square. Now substitute, that is 2A whole square, because AB is 2A minus BD is A. So when you simplify, you get root 3A, because 2A square is 4A square. 4A square minus A square is 3A square. So when you take square root, it is root 3A. Therefore, the altitude is root 3A. Now, look at this triangle ADB. ADB. I have shown it by a different color. Using this triangle, you can find all the required ratio. For example, sine A, if you take, what is the magnitude of A? It is 30 degree. So sine A will be equal to sine 30 degree. That will be equal to, what is the opposite side of this triangle? Opposite side is BD divided by hypotenuse is 2A, AB. Therefore, it is a by 2a, cancelling a once again, it is 1 by 2. So, sine 30 is 1 by 2. Similarly, cos a will be equal to, in the same triangle, it is adjacent side. Adjacent side is what? AD divided by hypotenuse is AB. Therefore, it is root 3a divided by 2a. Cancelling a, we get root 3 by 2. This is cos 30. Similarly, you can find tan 30. Tan 30 will be equal to BD by AD. That will be equal to A by 1 by root 3a. BD is A and AD is root 3a. Therefore, this is equal to, once again cancelling a, 1 by root 3. Therefore, we got three ratios: sine 30, cos 30 and tan 30 degree. Now, using the same triangle, we can also find sine 60, cos 60, tan 60, of course applying the definition. So, let us do that. Now, we have already seen sine 30, cos 30, tan 30. Now, you take sine B. Instead of A angle, you take B angle. Sine B is sine 60. But what is the opposite side of sine B? It is AD divided by AB. Therefore, you get root 3a by 2a. Cancelling a, but once again root 3 by 2. Similarly, cos B will be equal to cos 60, which will be equal to BD by AB. Then simplify, substituting, you get 1 by 2. There is a very interesting relation actually. Tan B will be equal to tan 60, that is AD by BD. AD, that is the opposite side, BD is the adjacent side. So that will be equal to root 3a by a, it is root 3. Cancelling a. Now look here, sine 30 is 1 by 2, cos 60 is 1 by 2, they are equal, and there is a very interesting relationship between them also that we are going to study later. Similarly, sine 30 is 1 by 2, cos 60 1 by 2, sine 60 root 3 by 2, cos 60 root 3 by 2, cos 30 is root 3 by 2, they are just reverse, and tan 30 1 by root 3, tan 60 root 3. So these are the values. So now just recollect, we have done 45 degree, then 30 degree and 60 degree together. So three ratios we have completed. Next one, of course you have to remember this, sine 30 1 by 2. Later of course I will tell you how to remember them, but repeatedly you have to use, so that it is very easy to remember. But there is a connection also that I will tell you later. So this is sine 30 3 sets and cos 30, sorry, sine 60 3 sets, sine cos 10. So these are the total. How many over now? So for 45 3 ratios, 30 3 ratios, 60 3 ratios, 9 ratios over. Of course 9 into 2 reciprocal, you need not remember, worry. So this is the second set. Now let us take next trigonometric ratios of 0 degree. Of course this is a little bit logical. You have to be very careful in understanding this. Please observe carefully. Consider a triangle ABC with B as 90 degree. Say this is the triangle ABC where B is 90. Now what we are interested is, we want to find what is 0 degree. Of course directly 0 degree drawing is not easy, not possible also. Let us see like this. See, what I do is, I take the angle C, and now you reduce the angle. Think carefully. Reduce the angle so that it is the hypotenuse is coming towards the base, that is BC. So this is now hypotenuse. That means I am bringing down A. Similarly, I will take one more case. So this is C, the same triangle only. Now I am still bringing it down. This is A. Now look at the three diagrams. ABC in the first diagram, AB is very lengthy. Next AB is smaller than that. Next AB is still smaller than that. That means I am reducing the angle C. So what happens, which you can see, as angle C decreases, the side AB also decreases. AB side decreases, opposite side keeps on decreasing. Now apply the logic. Suppose C is 0, what will happen? A will definitely coincide with B. A will coincide with B. Now based on that, we have to find what is the value of sine 0, cos 0, tan 0. Now look here, when C is 0 degree, AB will be 0 because A coincides with B. That is the thing. And sine 0 will be equal to, by definition it is 0 by AC because opposite side AB becomes 0. By definition sine C is AB by AC. But now AB becomes 0. So this is 0. This is the reason. Similarly, you see when C is 0, AB and AC will be equal because A coincides with B. So AC is same as BC. So this is another important logical reason. So cos 0 will be equal to AC by AC, which is 1. Then similarly, tan 0 will be equal to 0 by BC because opposite by adjacent. Opposite side AB becomes 0. So this is 0. Therefore, remember sin 0 is 0, cos 0 is 1, not 0, tan 0 is 1. So these are the three another important ratios. Next, same type of logic we are applying for tan sin 90 also. Let us take trigonometric ratios of 90 degree. Consider this triangle ABC once again. ABC. I am taking three separate cases like this. See here what I do is I am increasing the angle because C is acute angle because B is 90 degree. A and C both are less than 90 acute angle. Now I keep on increasing the angle C. See this is the second case. I am taking the third case. See I am still increasing it like this, like this. Now you see here in the diagram what happens is when you keep on increasing the angle C, two things happen. One is AB, the base, the point B keeps on coming towards C, coming towards C. Now imagine, suppose C is 90, what happens? Definitely B will come to C only. B coincides with C. So this is the thing. Therefore, now as angle C increases, the side BC also decreases. Now, when C is 90 degree, exactly when A becomes vertical, AC becomes vertical, B will go to C. It merges with C, coincides with C. Therefore, what happens is BC becomes 0. Therefore, what is cos 90? Cos 90 will be adjacent BC 0 by AC, so it is 0. Another interesting thing is when C is 90 degree, AC becomes AB. You can see here AB because B is coinciding with C, AB and AC both will be one and the same. Therefore, what is sin 90 now? Sin 90 definition is opposite. Opposite is AB, but AB is same as AC. So AC by AC, that becomes 1. This is the reason. And tan 90, very interesting, is not defined because AB by 0. Opposite is AB, base BC becomes 0. This is not defined because in mathematics we cannot divide any number by 0. So tan 90 is not defined. So this is what you have to remember. So remember these things once again. Sin 0 0, then cos 0 0, sorry 1, and tan 0 0. This is one set. Similarly sin 91, cos 90 0, tan 90 not defined. Therefore you can remember like this. See, there is once again connection. Sin 90 is 1, cos 0 is 1. Just reverse. Sin 0 is 0, cos 90 is 0. Then tan 0 0, tan 90 not defined. So these are the things you have to remember. Now let us first summarize because this is very important. Here afterwards you have to remember these ratios also. See, I have prepared a table like this. Trigonometric ratios, column, angle, row. So we will take only three first. Sine, cos and tan. Then we will write the angle 0 degree, 30 degree, 45 degree, 60 degree and 90. Totally 5 ratios, angles you have to take, 3 ratios, 5 to 3. 15 values you have to remember. But there is a very simple trick to remember. What you have to do is, observe carefully. First one is 0, sine 0, 0. Next half. Then 1 by root 2. Then root 3 by 2. Then 1. Of course, this line you have to memorize. So remember like this, 0, half, 1 by root 2, root 3 by 2, 1. So this is the rule. Now, second cos, it is very simple. What you have to do is, write the same number in the reverse order. First 0, then it is 1 by 2, then it is 1 by root 2, then it is root 3 by 2, then it is 1. I am repeating again. First row 0 half 1 by root 2 root 3 by 2 1, this you have to remember. The same thing you have to write in the reverse order starting from 90, the last column. Then tan you need not worry, you know that sine by cos, so 0 by 1, so it is 0. Second one you just see 1 by 2 divided by root 3 by 2, so you get 1 by root 3. Similarly 1 by root 2 by 1 by root 2 is 1, so this is 1. Another one is root 3, and the last one 1 by 0 not defined, therefore it is not defined. So this is the way to remember the table value. Now I am also showing you, though it is not absolutely necessary to remember them, but out of interest you can just look here. One more table you can prepare for the reciprocal ratio, t ratio and angle, and same thing cosec, then sec and cot. Reciprocal ratio 0 degree, 30 degree, 45 degree, 60 degree, 90 degree. What you have to do is now, first one is not defined because 1 by 0, second one becomes 2 reciprocal, third one becomes root 2, next one becomes 2 by root 3, last one is 1. Once you write this one, second one you need not worry, just write it in the reverse order. So first one is not defined, second one is 2, third one is root 2, next one is 2 by root 3, next one is 1, in the reverse order. Then tan also, just cot also, using this table only you can write. Not defined by 1 means not defined. Then 2 by 2 root 3, which is root 3, root 2 by root 2 is 1, 2 by root 3 by 2 is 1 by root 3, and it is 0. 1 by, actually it is infinity, so that is 0. So these are the total. You can count now how many, 1 2 3 4 5 columns into how many ratios, 6. So 30 values you have to remember, but there it is not absolutely necessary to memorize mechanically. Just remember the trick of preparation of this table. Anytime you can construct the table and find the values. So this is not a difficult thing. But in trigonometry, what is important is memory plays very important role. Students should be very good in remembering this formula also. Now let us work out a few simple examples today so that we can understand this concept easily. First question. In triangle ABC, right angled at B, AB is 5 centimeter and angle C is 30 degree. Determine the length of the other two sides. It's a very interesting question. Consider triangle ABC. So what is given is B is 90 and second C is 30. So this is given. One more thing is AB length is 5 centimeter. Therefore we have to find the other. Therefore what I do is, you can take any ratio. I take sine C. So sine 30. Sine 30 will be equal to AB by AC. Now substitute the given value. What is AB? AB is 5 divided by AC. Therefore now this gives you 1 by 2 because sine 30 is 1 by 2. Therefore what you have to do is 5 by AC will be equal to 1 by 2. So sine 30 is half, and that is also equal to AB by AC. AB is 5, so you have to just substitute. Therefore you can definitely find AC, which is cross multiplying, we get AC will be equal to 5 into 2, that is 10 centimeter. Therefore AC is 10 centimeter. Now even without Pythagoras theorem also you can find the value of BC. That is, take tan now, for example, tan 30 equal to opposite by adjacent. Using that also you can do. But I have done here like this. BC will be equal to, I will use Pythagoras theorem. You can do it by any method. So AC square minus AB square. AC square is 10 square minus AB square is 5 square. So this is 5 root 3 because 10 square is 100. 100 minus 25 is 75. Square root of 75 is 5 root 3. Therefore, the third side is 5 root 3 centimeter. So, you can write like this. AC equal to 10 centimeter, that is hypotenuse, and the base is 5 root 3 centimeter. So, this is the thing, of course, root 3 centimeter you have to write. So, this is the first example. Second example, very simple once again. In triangle PQR, right angled at Q, PQ is 3 centimeter, PR is 6 centimeter. Determine the angle P and R. So it is still simple. Consider this triangle PQR. So what is given is Q is 90 degree. So then, therefore we can just mark it. Then what else is given? Side PQ is given. This is 3 centimeter. And side PR is given. That is hypotenuse. That is 6 centimeter. Therefore, now sin R we can find. Sin R will be equal to PQ. Opposite side is PQ divided by QR. So substitute. That is 1 by uh, PQ by PR, 1 by 2. But we know that it is equal to sin 30 degree. Therefore, R must be equal to 30 degree. So the first angle is 30 degree. Second angle, once again, you need not find by other method. Directly you can write. Even you can find what is QR using Pythagoras theorem and then find it. But why to waste time? So you can simply say angle P will be equal to 90 minus 30, that is 60 degree. Because Q is already 90. Sum of the angle should be 90. Therefore, other should be 60 degree. So this is 60 degree. Thus, R is 30 degree, P is 60 degree. So this is the second question. Let us do one more. Example 3. If sin A minus B equal to half and cos A plus B equal to half, but condition is both angles must be, sum of the angle must be less than 90 degree. Second one is angle A is more than angle B, because A minus B is given. Find AB. So it is very simple actually. What is given is sin A minus B is half, cos A plus B is half. Now we have to do like this. Sin A minus B equal to half, but that is same as sin 30. Here afterwards you have to remember the angle and its corresponding value. Sin 30 is half. So this implies A minus B must be equal to 30 degree. So this you can write as equation 1. And then cos A plus B is half, but cos half means half is equal to cos 60. So A plus B is 60 degree. Therefore, now what you have to do is take the equation A minus B equal to 30 degree, A plus B equal to 60 degree, solve them. So how to solve? First add them 1 plus 2, that will give you B cancels. 2A will be equal to 90, A equal to 45 degree. Now of course you can use either equation 2 and find B, or you can also do by this one, 2 minus 1. When you subtract, you get 2B will be equal to 30, therefore B equal to 45. In any 15, third half of that 15 degree. Thus the first angle A is 45 degree, second angle B is 15. You can also check now. For example, you see A plus B must be 60, 45 plus 15 is 60, A minus B must be 30. That is correct. So this is the uh, last example actually. 3 illustrative examples we have taken, which is discussed in textbook. Thank you for watching this video. I hope you appreciate the way the problems are solved. I am going in a very systematic and slow manner, so that since trigonometry is the base, as I told you, and it also requires a lot of practice, please revise all the 3 lessons and then do this one. In the next lesson, let us take the exercise problems and then let us proceed. Hope you start enjoying the concept of trigonometry. It's a very beautiful branch of mathematics. Please revise and try to work out the questions which are remaining, so that definitely you will be preparing a very good strong foundation for future study of mathematics. Take care. Please subscribe if you have not subscribed, and share with your friends. Take care. Let us meet in the next lesson. Till then, bye.